In this video, we will be looking at inequalities, specifically grade 10 inequalities. Now, what is an inequality? Well, an inequality is a relationship that is expressed using mathematical symbols. Now, inequality symbols or signs are known as greater than, less than, or equals to, right? That means less than or equals to, or greater than or equals to. Now, the side or the direction of these signs. How do we know which is which? Well, let me propose the following to you. Let's say we have a tree, a big, beautiful pine tree or an oak tree. My tree's not the prettiest. Or we have a little flower, pretty little rose flower here. Or we have small grass. Okay, grass growing on a field, a rugby field or a hockey field. Okay, now, which one is bigger? Which one is physically bigger? Well, the biggest would be the tree. And which one's bigger between our grass over here? Which one stands taller above? Grass on a field, specifically a sport field, or flowers in a garden? The flowers are bigger. What do you notice here? What you should notice is that the mouth is always facing what is bigger. Alright. Now, how we can understand it or how we can memorize that is, imagine it's like a crocodile. Crocodile always wants to eat the bigger thing. So if the mouth is facing something, that means it is hungry and it wants to eat that thing. So whatever's on the side of the open mouth is bigger. Alright. Now, that's just how we place the sign itself. Let's take a look at what the numbers mean. Now, if I had to give you the relationship between x and the number 5, so let's say x and 5, and I had to tell you, well, x is less than 5. On a number line, what that would look like is if we were here at number 5, and if x is less than 5, can you list any numbers less than 5? Well, we could look at possibly number 4 over here. We could also consider 3, 2, 1, you could go to minus 9, everything over to minus infinity. And the way we would actually indicate this on a number line, if you're ever asked to do so, is simply an arrow there. You could draw a line with an arrow, showing that we are working with everything from minus 5 all the way over to the left. Now, remember in the beginning, where I said to you, we work with different signs where we said less than or greater than or less than and equals to. I would like you to take note of that last part, or equals to. When we speak of something that is equals to 5, we would put a stripe at the bottom. So, without that stripe, without that line beneath the less than sign, this means x is actually all of these numbers from minus infinity. It would be 1, x can be 2, x can be 3, x can be 4. But x cannot, I repeat, cannot be 5 itself. The only time x can actually include 5 is if we use the sign less than or equals to. So if we had x is less than or equals to 5, then x is everything from minus infinity, including 1, 2, 3, 4, and now x can equal 5 as well. And what that looks like on a number line is a colored in dot. So let's quickly summarize what I just said. In summary, if our inequality notation was something like x is less than, let's choose a new number, 7, our number line notation with the mouth being less than and not less than or equals to would be an open dot with a line going from this dot and the arrow closing on said line. Very important, open dot. Now, let's say our inequality notation was something like x is less than or equals to 7. We would have a closed dot at 7, closed over there, and again we would just have a line going from the dot itself to the negative direction, and very important to show an arrow, the arrow going to negative infinity over there. Now let me teach you one last notation called interval notation. Let's say we have the inequality notation of x is greater than or equals to negative 3. Now if you recall, we have the number line where we can write that down, and on that number line we would say, okay, cool, where's negative 3? Here it is. Do I need an open dot? Well, it's greater than or equals to, the equals to meaning we need to color that in quickly, Alrighty, fantastic. I've colored my dots in. Now, greater than meaning we need to go to the right because this would now entail all numbers greater than -3. We draw our arrow to say it could go on to infinity. And that we already covered. Now, the interval notation itself refers to all the intervals for which this interval or this inequality would be true. That means x could equal -2 if it needed to, as well as -1, as well as 0, 1, and you get the picture all the way on to infinity. And to write that as an interval, we would say, okay, cool, x, because that's the variable we're working with, is an element of, and where do we start? What's the smallest number on this number line? If you recall, it's -3. X can't be -4. We said it's greater than any -3 and including. So if we are starting at -3, let's just write that number there, -3. And where do we end? Well, we end at positive infinity. And for those of you who still struggle drawing the infinity sign, start with a C and then do a wiggly squiggly to complete it. But the easiest thing to start with is if you start with a C, your wrist will automatically take over. Now, to say greater than or equals to or less than or equals to has the interval notation of square brackets, and greater than or less than, the simple greater than or less than, is illustrated through round brackets. Now, -3 was, we would say x is greater than or equals to -3, so square bracket. And a very important statement, infinity is never included because we don't actually know what infinity is. It's so big, so it's a round bracket. There is your interval notation. Let's look at another example. Let's say I give you the interval of x is greater than -9. By now, you know we can convert this on a number line and see what it looks like. So we have our number line notation, and we say, okay, cool, we're at -9. Is it included or excluded? It's excluded, fantastic. And we're saying greater than, so it's everything to the right. Okay, cool. And what about the interval? What would that interval actually look like? Well, let's go look. We need to see our interval notation, and we're working with the variable x, so we say x is an element of, and where do we start? What's the smallest number here? Well, the smallest number is -9, and where do we finish? We finish at infinity, and that's excluded. It's as simple as that. Now, I would like to refer you to the final type, or type 3, when it comes to an interval, where we start at a number and finish at a number, and infinity is nowhere to be seen. Let's say I give you the interval of x, and now x is going to be between two things. What on earth does that look like? Well, let's say we're starting with x is greater than -8 and less than 6. So what that would actually look like is, if we had to look at our number line down here, and we had to say, okay, cool, where are we starting? Well, we are starting at -8, and it's included, so we can color that dot in. And where do we finish? We finish at 6. Why do I say where do we start and where do we finish? Well, if we had to isolate this interval and just look at the x greater than -8 over there, just that part, well, that looks exactly like the example we did before. And x less than +6, which we can see would actually start at +6 and go to the left hand side. Well, then what we can do is we can see, well, x is between +8 and -6, meaning it is all the numbers from -8 to +6. And what that would look like in the interval notation would be, we would start off by saying x is an element of, and so we list our two numbers again, our starting point, or our smallest number is -8, largest number +6, and then we go and we look at the inequality signs. X is greater than or equals to -8, the equals to sign giving us a square bracket, and x is less than +6, only less than giving us a round bracket. Now, your typical questions start off in something similar to what is on the screen. They would say solve for x if, and then they would give you a typical equation. But this equation doesn't have an equal sign, it has an inequality. Now, you will solve it using the same steps as an equation, alright? Your inverse operations. So this would be simplified as 5x is less than 12 plus 3, where 5x would be less than 15. And to isolate x, we apply the inverse operation of multiply, because this is technically 5 times x. So that would equal x is less than 15 over 5. Remember, 15 over 5 is technically the same as saying 15 divided by 5. And your answer there, x is less than 3. Now, your question paper will generally take it a step further and say to you, illustrate your answer on a number line. Okay, so we bring across our friend the number line. We'll have to draw it in the test. And we answer the questions. We see, okay, so we are working with 3. We look for 3 on our number line, and we see it is 0, 1, 2, and 3. And it is excluded, so it's an open dot. And then we see, okay, cool. So x is now less than 3. So therefore, we take it over to the left. And remember, it doesn't have an end number, so it goes to infinity. Okay, let's take it a step further. Let's look at another example. So they could say to you, solve for x if, and then they would present something like this. Minus 5x minus 3 is less than 12. And if you would like to, please feel free to try and solve this by yourself. However, note there is a sneaky trick coming along with the sign over here. And I want to introduce that now. When we multiply or divide with a negative, the sign is going to flip. So it says here, times or divide with a negative means flip. Let's see what on earth I'm talking about. Okay, so we're going to use the same steps. We have minus 5x is less than 12 plus 3. Same as before. Now we have minus 5x is less than 15. And if we had to take that a step further, we would say, okay, cool. So now x, and I'm going to leave my sign alone for a second. We have 15 divided by minus 5. When you multiply or divide with a negative, as you can see here, we have a minus 5 at the bottom. Your sign needs to flip around, meaning it will no longer be, x will no longer be less than, x will now be greater than. So your final answer here is x is greater than minus 3. Alright. And if we had to convey that over to a number line, what we would get essentially would be something in the lines of identifying minus 3 here, drawing an open circle, and then seeing it's greater than minus 3, so we go to the right. Very important to remember that when you multiply or divide with a negative, we flip the sign. Let's look at another type of problem here. We get solve for x if 2x minus 1 over 3 is greater than or equals to 2x plus 1. Now this is an inequality question or an inequality equation with fractions. It is a form or it's a type of question you can expect to see. So let's look at the steps. Again, we will treat it like an equation. And if you remember with equations, we need to identify the LCD or the lowest common multiple of all the denominators. So LCM equals 3, and we multiply everything in this equation with that. So if you had to multiply it with 3 over 1 here, you would see the 3's cancel out, and what you do on the left hand side you have to do on the right hand side. So we are going to multiply this entire expression with 3 over 1, and what that equals is the following. We get 2x minus 1 is greater than or equals to 3 brackets 2x plus 1. And if you multiply in, or if you distribute that 3 into this bracket, what we then get is the following. We get 2x minus 1 is greater than or equals to 6x plus 3. And now we follow simple steps. Let's take the 2x over to the right hand side, like such, and let us bring this plus 3 over to this side to become minus 3. So what we then will have is we will have minus 3 minus 1 is greater than or equals to, please note the sign remains as is unless we are multiplying or dividing with a negative, and then 6x minus 2x. Simplified there, minus 4 is greater than or equals to 4x. Now, we need to get rid of this 4. We need to isolate the x. And here we have 4 times x. So to get rid of that 4, we are going to divide by a positive 4 to cancel them out. So that's minus 4 divided by a positive 4. Are we dividing by a negative? No, we are dividing by a positive. Please, I'm going to repeat that. If you look at what we are doing over here, we had minus 4, and we divided it with a plus 4. So your sign does not change. Very important. So, because we are taking a negative divided by a positive, the answer would be minus 1, sign not changing, So greater than or equals to x. And remember, we want to say our x first, so we would say x is less than or equals to minus 1. So solve for x if, and now we have one where x is squished between two numbers. Remember when we discussed the interval earlier. Okay, and that is a standard form where we have x between two numbers. And how we are going to solve this is we're going to do it simultaneously. Alright, so that means we are going to treat them like two different inequalities. We'll have the yellow rectangle, and how we would solve that is, well, we would start off by going minus 3 plus 1 is less than or equals to 3x. But we can't forget the other one. So we are going to look at this orange rectangle, or brown, and that would give us the solution 3x less than 5 plus 1. So if you see what we did there, we technically solved it simultaneously. We took this minus 1 over to that side. Likewise, we took the minus 1 over to that side. And so we will repeat for all inverse operations. This would become minus 2 less than or equals to 3x. My apologies, my pen gave up on me there. 3x, which is less than 6. Fantastic. Now we need to isolate the x, so we divide by 3. So we have minus 2 over 3 less than or equals to x, which is less than 2. Again, why have the signs not changed? The signs remained exactly the same. Why? Because we divided by a plus 3 over here. Okay. The final thing you need to know in inequalities are specified intervals. Now, let's say I give you the inequality notation of x is greater than 2. But now I tell you x is an element of reals. That's what this means. X can be, so element means x can be any real number as long as it is greater than 2. So what that means is x can be 2, or no, sorry, just greater than and not equals to. So x cannot be 2. But now x can be 2.1. X can be 3, x can be 4, x can be 2.99999 to infinity. You understand? X can never be 2, but x can be anything greater than 2. Any decimal, any power, as long as it's greater than the value of 2. And what that looks like on a number line is exactly what we have done this far in this lesson. We would have the number positive 2, open dot, and then we would have a line going from it to positive infinity. The line technically means we are including every number past 2. Now here's where the trick comes in. Let's say I give you the same inequality notation, x is greater than 2. But now I say x has to be an element of integers. If you recall, an integer is any number between minus infinity and plus infinity, but no decimals. No decimals are included. So what that looks like is if we have minus 2 over here, see it's an open dot, then we could go up from that. So then it could be 3, colored in. It could also then be 4, 5, 6, 7, 8, 9, and 10. Alright, now for the sake of explaining the next one, let's make, please note for the video, I've changed this plus 2 to minus 2. So let's take a look at what that interval would look like. So we have minus 2, and again, it cannot be included. And it's anything greater than that. So now we have minus 1, 0, 1, 2, 3, 4. Okay, cool. What if we change our interval to whole numbers now? If you recall, whole numbers are all numbers greater than 0, including 0. So if x is greater than minus 2 over here, well then we can start off minus 2, but that's not a whole number, so it cannot include that. Let's erase it then. Where can we start? Well, we can start at 0. And luckily for us, that's included. So 0, 1, 2, 3, and so we go on. And likewise, if we had to say x is an element of natural numbers, it would be the same thing. Except, of course, natural numbers do not include 0. So let's remove 0 over there. So our list of natural numbers that are greater than minus 2 would start at positive 1 and go to positive infinity, with nothing between the natural numbers. Alright, ladies and gentlemen, please like, subscribe, and share, and become a part of the Whiteboard family. Goodbye.